Okay, so what we're going to talk about is the difference between a square root and a cube root. The last week or so, we have just been working on square roots. So something like if you had the square root of 36, you are looking for a pair or two of the same number. So you would break it down and say, what times what is 36? Well, we all know that 36 is a perfect square. And so that is where the square roots come from because we are trying to see what times what will give us this. Now, every single time we're looking at a square root, we are assuming that there is an imaginary 2 here because that's telling us that we're looking for two of the same numbers inside of here. Squares are pairs. That's what the whole process is. Now, whenever you look at something different, like a cube root, okay, and a cube root is exactly what it says, okay? You are looking at a three-dimensional object, such as this, okay? And so let's pretend that we were looking at this and we're trying to say, what is the cube root of this? And so what you're really doing is doing the length, the height, and the width of this particular thing, okay? So you're trying to see what times what times what. It's going to be to the third. So cube roots, let's say the cube root of 27, okay? And you have to put the little 3 there. If there's not this little 3, then you're just assuming that it's the square root. So the cube root of 27 is going to be 9 times 3, which is actually 3 times 3 times 3. And so that means that you have 3 of the same numbers. So you pull that out and it becomes 3 the whole number. That means this bottom is 3 across, going up is 3, and across the top is 3. So this is why it is a cube root, because it is a three-dimensional object and you're trying to find 3 of the same. The square roots are a little bit different because you're just looking for 2 of the same. So let me give you a couple of examples. If you had the cube root of, let's say, 81, okay, and remember you have to put the little 3 there. Or if you had the square root of 81. Now these are two very different things because here you're looking for pairs, which is going to be 9 times 9. Or you could break it down further to 3 times 3 times 3 times 3, but still the square root of 81 is going to be 9. Because if you had a square, 9, 9, that's where you get your number from. Okay? Now, when you're looking at 81, you are looking at cube roots. So this could also be 9 times 9. Or breaking it down further, 3 times 3 times 3 times 3. So now what you're doing is because you're looking for cubes, you're looking for groups of 3. So you're going to pull out these 3 outside of the root, and you will have 3 root 3. So even though they are the same numbers, they are looking for two very different things. Which one of these is the square and which one of them is cube? Remember, when you're looking for square roots, okay, you are looking for pairs or two, okay, of the same. When you are looking for cube roots, you are looking for 3 of the same. Okay, and that could be a number or it could be a variable. Either one of those is fine. Okay, so we're going to do one more example just to make sure. Let's do the square root of 100, x to the fifth, y to the second, z to the third. Okay, now, then we're also going to do the exact same problem with the cube roots. So you've got a 3 here, 100, x to the fifth, y to the second, z to the third. Okay, starting off with the squares is going to be 10 times 10, and then 1, 2, 3, 4, 5, 1, 2. Now, a lot of you can just look at this and know exactly what to do because you divide the variable by 2 and you're good to go from there. But what you actually do is you pull out a pair of 2's and you pull out a pair of 5's. 5 times 2 is 10. Then when you're looking at the pairs here, you have x squared. You have 2 pair. 1 pair of y's, 1 pair of z's. And so then what you have left in the house or in the radical is an x and a z. Again, you could always just divide these by 2. Okay, now when you're looking at the cube root, it's going to be the same concept. But now you're looking for 3's. So you're going to have 2 times 5 times 2 times 5, and that's to get to the 100. Are any of those groups of 3's? No. So you are going to keep the 100 underneath the radical sign because there's not any group of 3. Now, instead of dividing by 2, now you're going to divide these by 3. So you're going to have an x out here and 2 x's left inside. You're going to have 2 y's because there's not 3 of those. And then you're going to have a single z out here. So your final answer is xz, the cube root of 100 x squared y squared. Okay, I hope that helped you, and we are going to do some more practice.